So for section 2.1, we looked at an example for sketching a polynomial described by like intervals of positive, negative, decreasing, and increasing. And so what we want to do when we're looking at these is notice that the positive and negative intervals contain the same values. And so for these intervals, they're giving us some x coordinates and they're describing them in an interval notation. So it says from negative infinity to negative 4, the graph is positive. And so remember that positive means that it's above the x-axis. So that means that from negative infinity on the x-axis to negative 4 on the x-axis, the graph's above the x-axis. So remember, negative infinity is referring to the left. So the section from negative infinity all the way to the left until 4 is going to be graphed above the x-axis. So to kind of mark up my graph, I'm going to highlight above so that I know my graph is going to be in this area. I don't know necessarily where it's going to go. I just know that it's going to be above the x-axis for that section. And then it's below the x-axis. I'm sorry, it's still positive also between negative 1 and 4. So between the x values negative 1 and positive 4, the graph is also positive. So this section of the graph is also above the x-axis. And then, so that was positive. And then the statement says that the graph is negative from negative 4 to negative 1, and then from 4 to infinity. So notice that these kind of line up with what the rest was. So if it isn't positive, notice it's negative. So it's telling us that the graph is below the x-axis between negative 4 and negative 1, and also between positive 4 to infinity. So this whole right side of the graph from that value positive 4 to infinity is below the x-axis. So the question wants us to identify x-intercepts, turning points, separate them by maximum and minimum, and identify the end behavior. And so if we think about what's happening here, so that means my graph's above the x-axis, then it's going to cross over and go below. So that means that at this point where it changes from positive to negative, that's going to be an x-intercept. So we're going to have an x-intercept at negative 4, 0. And then it's going to come back and cross over again at negative 1. And then our last x-intercept, it's going to come back and cross over again at 4. So we have 3 x-intercepts, negative 4, 0, negative 1, 0, and then positive 4, 0. And so really what's happening here is they're giving us an estimation of pieces of the graph. So what this shows us is that the graph is going to look in general, and I'm just going to sketch this and then erase it because I still have to look at increasing and decreasing. But this tells me that I'm going to start up here, it's going to cross through, it's going to go through, it's going to cross that way. So my graph should look something like that. However, it might not look exactly like that because I haven't taken into account where it's increasing and where it's decreasing. So I'm going to erase that so that we can talk about that section. What I do know for sure, though, is the end behavior. So because on this side of the graph it's positive and there's nowhere for it to turn, I know that this section is going to go up and that this section is going to go down. Okay, so what I know about this graph is that my end behavior is as follows. So as x approaches negative infinity, our y value approaches positive infinity, right? So on the left side of our graph, the arrow is pointing up. And then as x approaches positive infinity on the right side of our graph, y is approaching negative infinity. So as x approaches infinity, y approaches negative infinity. And so if we think back to end behavior, this isn't asking us to identify what type of function we have, but notice they're going opposite directions. So that means that we have an odd function, and the fact that it's negative on the right is telling that we have a negative leading coefficient. Okay, so this is a negative odd function. if we were writing the equation for some reason. Okay, so right now we know that we're going to have this kind of parabola shape going on between the two x values because it's negative there and it needs to touch them both. And then we're going to have like an upside down parabola shape over here. So what is going to tell us where those values are is this increasing, decreasing. So let's do increasing first just because that's what color I chose. So if it's increasing, it's going up from negative 2.67 to 2. So that's telling me that the graph is increasing, which I knew, right? I know that this is going to be like that, and then this is going to be like that. And so it's increasing between those values. And so what this tells me is specifically where my minimum and my maximum are going to show up. And so notice that the two numbers here, so I get a negative 2.67, that's here, and a positive 2, is also in that statement. So what I'm going to do is kind of draw a dotted line at those x values to give me a guideline as to where my minimum and my maximum should be. So 2 is here. So since I'm highlighted up here, I'm going to just mark this. And so I know that my maximum is going to be at that point because of where I am. So I'm in the top part of the graph, and so I know it's going to change and become my maximum on that line. And so that means that I can make this y value anything that I want as long as it's positive and in that highlighted region. And so I could put my point like here if I wanted, or up here, or up here. It doesn't matter as long as that y coordinate is at 2. Okay, so that means that I know it's going to go like this and hit that and then turn. And then similarly at that negative 2.67, so this one I have to estimate a little more. So it's between 2 and 3, closer to 3. So I know that the x coordinate of my minimum for this, and again, I can pick any y value. I'm just estimating this graph. So let's just say it's here. That's where the minimum value is going to be. So it's going to go through this. Oops, let's try that again. It's going to go through this point and then go back up to the other x-intercept. And so notice that it's fitting all of these descriptions now. So it says that it's increasing, but from negative 2.67 to 2. So see how our graph is increasing. So the slope changes a little, but it's still always, the next y value is always bigger than the last. And then it's decreasing from negative infinity to negative 2.67, and then again from 2 to infinity. Okay, so when we graph using these positive and negative intervals, we start with the x-intercepts, and you can highlight or just note somewhere the area that you're going to graph in. So maybe you could write like a plus sign up here and draw the line is one other thing that we did in class. And then so plus sign would be here, and then maybe draw the lines down here and say that it's negative, and divide it up that way, just so you get a visual of where the graph is going within each of those sections. So then looking at our graph, the local minimum is all that we can say. It's at x equals negative 2.67. So because I just guessed on the negative 5, I'm not going to write that the minimum is negative 2.67 comma 5. Same thing with the maximum. So my turning point at that's a maximum is at x equals 2. So that's how you sketch a graph using the description of the intervals that are positive, negative, and increasing or decreasing.